so we'll move on then. So question 3. Okay, and again, look at the top of the question. It tells you what the question is about. Okay, and that gives you a bit of an idea about what you need to be thinking about. So the question is about oxygen and substances containing oxygen. It says complete figure 4 to show the arrangement of the outer shell electrons in an oxygen molecule. Okay, it then says use dots and crosses to represent the electrons. Okay, so that will be my dot and cross diagram. Okay, so I would have in the exam, I would have a periodic table, or I would have information telling me, so I could work out how many electrons would be in that outer shell. Okay, so for oxygen it will be 6. Okay, and they share 2 pairs between them because it's a double bond. Okay, which leaves you with 4 electrons in both of those oxygen atoms, which are not bonded to anything. Okay, just ignore that little squiggle there, that's nothing. Okay, and then it then says name the type of bonding in an oxygen molecule. Well, because it's 2 non-metals, but oxygen is a non-metal, okay, that is covalent bonding. Covalent bonding is sharing of electrons. Okay, way to remember that, to think about it, is covalent, cooperation between them, they're sharing those electrons. Okay, so next bit then, explain why oxygen has a low melting point. Okay, and so there are weak intermolecular forces. That means if you've got a molecule like that one there, and you've got another one and another one over here, they've only got weak forces between them. So there are weak intermolecular forces which require little energy to overcome. And I think I'm going to add to that that this means that oxygen boils at low temperatures. I could have probably got away without that, but it's just about making it as clear as possible that I really understand what this is about. Okay, so we'll move on to the next bit of that question. So magnesium oxide is produced when oxygen reacts with magnesium. Okay, it says balance the equation for the reaction. Okay, and balancing equations will come up always on a chemistry paper. You've expected to do it somewhere along the line. This one isn't a very difficult one, actually. Okay, you've got magnesium and oxygen. Okay, remember you're not allowed to put numbers down here, you've got to put numbers in front of them. Okay, so I've got 2 magnesiums reacting with O2 to give me 2 molecules of magnesium oxide. Okay, and then we've got the next part of the question. It contains magnesium ions, which are Mg2 plus, and oxide ions, which are O2 minus. Okay, it says describe what happens in terms of electrons. So again, I've underlined describe there. I've underlined a bit about electrons. When magnesium atoms react with oxygen atoms to produce magnesium oxide. Okay, and so magnesium will lose electrons to become positively charged, and oxygen gains electrons. So there's 2 marks just for saying that. So you can see in these sort of questions, you don't necessarily have to write a huge amount to pick up the marks. Okay, and it's not like a 6-mark question where you've got to write it in paragraph form. Okay, and I've just added to that, for the 3rd mark, that 2 electrons are transferred. Okay, so that's the 3rd mark. So there's 2 marks for this bit, a 3rd mark for saying that bit there. Okay, last little bit there. Okay, just a quick question. What are nanoparticles? And they are particles between 1 and 100 nanometers in size. Okay, and that's just worth thinking that actually that's just a 1 mark question. It's just something that you'll either know or not know, but it's worth trying to remember all those key facts because it's not just about 6 mark questions. It's about recalling those little bits of information that are going to get you an odd extra mark here and there. Okay, on to question 4. Oh, sorry, the next part of question 3. So it tells you that the furnace is lined with silicon dioxide. Okay, now if I look at that compound there, I might not know much about silicon dioxide, but what I know is that because it's silicon and oxygen, it's got to be covalent. It's a covalent structure. Okay, because it's 2 non-metals bonded together. It tells us that the temperature of the furnace is 1500 degrees C, so it's a very high temperature. Okay, and we've got a little picture there. Okay, and then explain in terms of structure and bonding. So again, explain is the key word there. Why silicon dioxide is used to line furnaces. Okay, so what we're looking at there, you might think, well, it's a high temperature, so it's obviously something to do with why has silicon dioxide got such a high melting and boiling point. That's what we're looking at, and we can tell all that just by looking at the question. So, silicon dioxide has a high melting point, okay, because all atoms are linked to other atoms by covalent bonds. Okay, and I'm just going to add to that as well, so which are very strong. Okay, and then for the final mark, a lot of energy is required to break these bonds. And I'll just add on to that as well and melt the substance. Okay, so that's the remainder of that question there. Do people need a little bit longer on that one? Sorry, I'll just pop that back up there for a second. Okay.